All right, so what we're going to do now is we're going to work an example of a real life problem, something that is dear to most of y'all's heart as well as mine, money, and how to make money grow to make it benefit you in the long run. So there are two formulas we need to know to deal with money. We're going to be dealing with interest here. So we have two formulas. We have one formula which is A equals P, and I'm going to go over what each letter means. 1 plus R over N to the power of NT. My other formula is A equals PERT, or I call it PERT. Most people call it PERT. So here's how this works. If you see the word continuously, if something is compounding continuously, if interest is compounding continuously, you will always use PERT. Always, always, always. If it does not say continuously, you're going to use this other equation. Now, what does P mean in both equations? Well, P is what we call our principal. I don't care if you remember the word principal, but you need to know that this is your starting amount. How much money are you starting with? So that is the same for both of these. Here, E, this is what's called Euler's constant. And it represents a number and it is built into your calculator. All right, 1 is 1. R in both of these equations is your interest rate as a decimal. So you know you get things like it's at a 5% interest rate or a 7% interest rate. Well, you've got to be able to convert that percent to a decimal because this is going to be your decimal. Your R needs to be the decimal. Do not put, if I tell you 12%, do not put 12 right there. You have to put 0.12. Your N represents the number of times compounded yearly. Now, N will always be given to you in a word, such as yearly. If something is compounded, well, not yearly, but annually. That's a bad example. Annually. If something is compounded annually, your N is going to equal 1. They could say something like quarterly. Cannot spell. Well, there's 4 quarters in a year, so N would be 4. They could say monthly. And I think you kind of get the idea. Monthly is going to be 12 months in a year. They could say it could be compounded daily. Well, that would be 365. You could even go down as far as saying it's compounded hourly. You can go down to it's compounded every second. And then it says compounded continuously, which would be even every nanosecond. So that means it's always compounding, that every single moment. Because if you even do it every minute, there's still other minutes that's not being compounded. All right, so the key thing here is N is always going to be given to you in a word problem as a word as it references time. Annually, quarterly, monthly, daily, hourly, something along those lines. Now your T is going to be your number of years. So if you're dealing with we're going to pretend like you go and put money in a savings account and you totally forget about it and you never have to. I know that's never really going to happen, but we're going to see how that money could actually grow over a long period of time. So maybe like 20 years or 25 years, because believe it or not, interest does come into a huge part in people investing over long periods of time. But it's not so much these formulas that they come into. And later on this semester, we'll get into stuff like annuities. We'll talk about dividends and things along those lines in the pre-calc, because I try to work money in as much as I can in the pre-calculus so you kind of get an idea of money sense, which is really a big skill you have to be able to adult. All right, so here's our setup. Here's our two formulas. So let's work a problem. All right, so let's look here. This is all going to be around a word problem. It's going to say like you have a starting amount of $5,000 to put in a 401k that's going to have an annual return rate of 5% over 20 years. So it's going to say something along those lines. And then it's going to say, how much money after 20 years would you have if the interest is compounded annually? How much would you have if it's compounded quarterly? How much would you have if you compound it monthly? How much would it be is if you compound it daily and then continuously? Now, if you notice in this part, we're not adding any money to it, because when you start adding money to it, you're going to start having, say, if you could do an annuity where you're going to add money at a set given time, and there's other equations for that. So in this case, we're not adding money. We're just starting with the 5,000. We completely forget about it and just leave it there for 20 years. So let's look. So annually, because it doesn't have the word continuously, it means we're going to use this formula right here. Annually means that my n is going to equal 1. So let's use some different colors here. So all I do is plug everything in. My amount is going to be my 5,000 times 1 plus my interest rate, which is 5%. So my decimal is 0.05. So 0.05 divided by my n, which is 1, over 1 times 20. When you throw this in a calculator, just throw it in a calculator, the answer you get is going to be approximately $13,266.49. So that's not bad. $5,000, it almost tripled in 20 years, and you didn't do a single thing. You just sat there. And that's if you had an average of 5%. Now let's do this quarterly. In quarterly, my n is going to be 4. So I'm going to change this 1 to a 4. Other than that, all the math stays the same. 5,001 plus 0.05 divided by 4, and then 4 times 20. When we do this, we are going to get $13,507 and 42 cents. Not bad. It's a little better. If you notice, it's a little better compounding quarterly versus annually. So monthly, my n is going to be the number 12. So everything's the same. 5,001 plus 0.05 over 12, but now it's 12 times 20. When I do this, I get $13,563.20. All right, still getting better. So we're starting to see a trend. The more that it's compounded with it, the more times it's compounded, the better off it's going to be for you, the person. Compounding annually is actually the worst way for you to go. You can see that's the least amount of money you're going to get. So daily, well, my n, we're going to say there's 365 days. We're not going to do decimals or anything like that. And we just replace the 12 with 365, and it should be a better than this $13,563. Let's see how much better. 5,001 plus 0.05 over 365, 365 times 20. When I do this, I get $13,590.49. So by far, the best one to date. So if I have my choice between these first 4, I'm taking daily every time. Sometimes I would take daily at a lower interest rate by doing calculations, knowing that ultimately it would work out better for me. Because they may try to say, hey, I'll give you a higher interest rate annually, but you get a lower interest rate monthly. But when you sit and do the math, you realize the lower interest rate compounded more is benefiting you better than the annual. It's one of those shockers, those tickets you're like, ooh, I can get 7% annually or 5% monthly. Well, I'd rather take the higher percent, the 7%, but it actually works out to your disadvantage. So let's look at continuously. Continuously means it's always compounding. There's not a set time frame. It's always compounding, and we have a special formula for that, which is PERT. Your amount equals your principal times e to the power of RT. So this is just going to be 5,000 e to the 0.05 times my 20. So E is built into your calculator. All these calculators have buttons that have an E on it. When I do this, and I plug it in the calculator, this should be better than daily because daily is only compounded every 24 hours. This is always compounding. Every second, every nanosecond, every picosecond, it's always compounding. And in fact, I get $13,591 $2.41. By far the best option you would have. You're not going to find anything in the real world where it compounds continuously unless it's a bank trying to take money from you. Whenever it's going to benefit you, you're not going to find anything continuously. You generally find annually or quarterly. And they generally, the annual rate, they will give you a higher interest rate than the quarterly. But make sure you do the math, because at a certain point, it's actually better to do the quarterly, the lower interest rate, depending on your principal amount and how long you're going to actually have it in there. So this is it. Voila. Not a terribly bad. It's formula-driven math. It's just really in the analysis part of it is where this has the power. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.